Today we started off with a quiz. Uh, Find lines parallel and perpendicular to the line y equals 2x plus 7 at the point 2, 5. First thing is, you have a parallel line. You have the same slope. So we want to find the line through 2, 5. This slope 2. Using form, y equals mx plus b. We substitute 2 for m because m is the slope. And we know that y equals 5 when x equals 2. So 5 equals 2 times x, but x is 2, plus b. So b has to equal 1. I didn't solve this equation, but 2 times 2 is 4. If 4 plus b is 5, you don't need to have to do a lot of algebra to figure out that b must be 1. Of course, if you get something a little weirder than that, you're going to have to solve the equation for b. But the point is, if we know the slope and a point, we can always plug into y equals mx plus b. Alternatively, use the point slope form. And if you use that form, you get y minus 5 equals 2 times the quantity x minus 2. So y equals 2 times the quantity x minus 2 plus 5. Again, not going through all the steps, but adding 5 to both sides. So the y minus 5 becomes just y. The 2 times the quantity x minus 2 becomes 2 times the quantity x minus 2 plus 5. And then we just use the distributive law. 2 times the quantity x minus 2 is 2x plus 4. And we add that to 5, and we get 2x plus 1, giving us the same result. Either way, the equation is y equals 2x plus 1. Now, I said I encourage a graph. So let's see what this looks like on a graph. What's the graph of y equals 2x plus 7? I'm going to make, I don't have a lot of room left on the board, so I'm going to make this a little bit small. But The x-intercept occurs when y equals 0. If we substitute y equals 0, we get 0 equals 2x plus 7. And again, I'm not going to go through the details of solving this. We just add a -7 to both sides, add the equation -7 equals -7. We're going to get 2x equals -7, and x is going to equal -7/2. Y-intercept occurs when x equals 0. And again, when you're writing these out, you want to write those things out so you remind yourself and think about the fact that when you're looking for the y-intercept, that occurs on the x-axis. When you're looking for the x-intercept, that occurs when you're on the x-axis and y is 0. And the y-intercept occurs on the y-axis where x is 0. So we can plug 0 into the equation and we get y equals 2 times 0 plus 7 equals 7. And now we can sketch a graph. Put the line y equals 8 up kind of high on the y-axis. And slope being 2, there's no reason I can't go ahead and put the line x equals 8 here. Now you don't have to line off your graphs the way I do, but it's very convenient. It gives you a better scale for the graph if you do. Because now I can draw the line halfway between y equals 8 and y equals 0, and that's y equals 4. And halfway between x equals 8 and x equals 0 is x equals 4. So I know where 0, 4, and 8 are on both axes. So now x equals -7/2. Okay, that's -3.5. I can estimate where y equals -4 is. It's going to be spaced below the x-axis at an equal distance from the y equals 4 line. So we'll say maybe y equals -4 here. And then -3/2. Well, that's just a little bit above -4. So I'm going to draw y-intercept about here. And the x-intercept, I do this a lot. Pay attention to what I'm doing, so take a lesson. Don't do like I do. X should equal, the x-intercept is -7/2. So that would be over about here. Almost as far to the left of the y-axis as the x equals 4 line is to the right. The y-intercept is 7. So when x equals 0, y equals 7. So the y-intercept is going to be about here. I'm not going to label those just yet because I want to see what else I get on this graph. But my line y equals 2x plus 7 is pretty easily graphed by figuring out the intercepts. And there are, of course, other ways to do it. I do really, really strongly recommend that you draw them out by hand because clicking around on Open Math is not a good way to retain this. It's much different than the act of using your hand to sketch it. You engage your brain differently. Now, whatever works is okay. As long as you can do it on a test, it's fine. Okay, so anyhow, there's the line y equals 2x plus 7. Now, we want a line parallel to 2x plus 7 at the point 2,5. Where's the point 2,5? Well, x equals 4 is here. So x equals 2, we could even sketch a line here for x equals 2. And y equals 5. Well, 5 is between 4 and 8, and twice as close to 4 as it is to 8. So I'm going to say that that point probably is right here. There's the point 2,5. And we want a line parallel the original line, so it's going to have the same slope. So I just kind of eyeball parallel, and it looks something like this. This line, again, goes through the point 2,5. By sketching it, I can estimate its x and y intercepts and check that against its equation. It looks like the y-intercept is about 1. In other words, we've got 4 units from the x-axis to the y equals 4 line. This looks like it's about 1/4, maybe a little more. Maybe it's about, maybe it's about 1.3 or something like that. And the x-intercept appears to be at about -1. Now, that's not a real good, well, it's not a terrible approximation. What's the x-intercept of the line y equals 2x plus 1? Well, you let you let y equal 0 and you solve it and you get -1/2. And I estimated -1 here for the y-intercept. Okay. And we can let x equal 0, we get y equals 1. Well, actually, my y equals 1, then I upped the estimate to about 1 1/3. It was just an honest estimate. We find that the x and y intercepts of this line that we found by the algebra matches our sketch quite well. Not perfect, it is pretty good. Okay. Well, now we want to draw the line perpendicular to the original line through the same point. Not at all. Excuse me a minute while I get the right board out. Okay, well, now we want a line perpendicular at the same point, 2,5, perpendicular to the original line. So I can now say that the line perpendicular through the point 2,5, I think it was. I want to make sure it's kind of critical to get that right. Okay. Line through the point 2,5. Has a slope which is negative reciprocal. Y equals 2x plus 7. So slope is 1/2. Then a line through 2,5. Slope 1/2. I'm going to go to y equals mx plus b. It's a lot easier to remember that than it is to remember y minus y1 equals m times x minus x1, especially long term. But of course, it's your option to do it by either formula. But using the y equals mx plus b formula, becomes y equals 2 at the 0.25, y equals 5 at the 0.25. Slope is m, which is 1/2, and it's the negative reciprocal. I didn't put the minus sign in. So again, we're doing the line through 2, 5 with a slope of negative 1/2. So we're going to replace m, in this case, by negative 1/2 x plus b, which is, yep, okay, it's not negative 1/2 x. X is 2. So let's write that correctly. Negative 1/2 times 2 plus b. So you get 5 equals negative 1 plus b. And you get b equals 6. So the formula is y equals negative 1/2 x plus 6. We can double check that. If x is 2, negative 1/2 of 2 is negative 1. Negative 1 and 6 makes 5. And if x is 2, y has to be 5. And that's exactly what we get. I always advocate checking. Let's come over to our graph and see if this makes sense. I'm going to get the chalk out of there. Um, what to do when that happens. Okay. So again, we got the 0.25. Now that I know where the lines are going to be, I can label this point on my graph. So there's the 0.25, 2 units to the right of the x-axis, 5 units, 2 units to the right of the y-axis, 5 units above the x-axis. If I go at a perpendicular to this line, now I'm going to have to situate myself over here so I can better see what a perpendicular is. So I'm blocking the board. I'm just going to sketch what I think is about perpendicular. Now, it's got a little bit too much negative slope, the way I sketched it, but still, it's plausible. If you have labeled the y-intercepts of the original graph, you recall that those were at 0, 7, and at negative 7/2, 0. Where does it appear this line crosses the y-axis? Well, it appears to me that that line crosses the x-axis about halfway between y equals 4 and y equals 8. So I would estimate the y-intercept of that graph to be about 6, maybe even a little less than 6. And I'd estimate the x-intercept, it looks a whole lot like x equals 8. Now, as I said, it has a little too much negative slope, but that means my picture is even a little worse. But let's see now what the intercepts of this line should be. Okay, well, Well, the y-intercept should be 0, 6. I said it was pretty close to 0, 6, maybe just a little less. So it's actually just a little bit low. Getting signals out there. Okay, so we got a little correction. I forgot to put the negative sign on there, which would have been, we'd have found out. We would have gotten the y-intercept of 0, negative 12, which isn't even close. We were on the wrong side, but that's because I didn't put the negative in front of the 1/2 there. Okay, so the y-intercept is 0, 6. X-intercept 0 equals negative 1/2 x plus 6. We'll add negative 6 equals negative 6 to both sides to get 0 minus 6 equals negative 1/2 x plus 6 minus 6, which simplifies down to negative 1/2 x equals negative 6. Multiply both sides by negative 2. And we get x equals 12. Okay. Now, as I said, my graph was a little too steep this way. Should have been a little less steep, and it should have actually had an x-intercept out about at x equals 12. And you can see the graph, it's about here. So it's not a spectacularly accurate graph. Came out pretty good on the y-intercept. By the time we got to the x-intercept, we were hurting. Okay. Now, what I want to do next is I've got this point where the original graph, the y equals 2x plus 7 graph, crosses the y equals negative 1/2 x plus 6 graph. Now, the negative 1/2 x plus 6 graph isn't overly accurate because, again, the y-intercept is pretty close, but the x-intercept comes up a significant amount short. Still, we have this picture, and we see that these two lines intersect, apparently, just a little bit to the left of the x-axis. So the next thing we want to do is find a point where the lines y equals 2x plus 7 and y equals negative 1/2 x plus 6 intersect. Now I'm going to say it just kind of briefly here. At the intersection point, y coordinates are the same. And for the first equation, your y coordinate is 2 times your x coordinate plus 7. For the second equation, your y coordinate is negative 1/2 times your x coordinate plus 6. Now then, we can set 2x plus 7 equal to negative 1/2 x plus 6. And when these two are equal, we know that the y coordinates are going to be equal. Let's just go back over the logic of what I just wrote down. We have two equations of the lines. The lines intersect at this red X, just a little to the left of the y-axis, up around x equals 6 or a little more. Okay? We want to find the exact coordinates where those two lines would intersect, because the line I drew for the equation y equals -1/2 x plus 6, it's in approximately the right place, but the y-intercept looks to be like, or the x-intercept looks to be about 8 rather than 12. So what we do is we say, well, here's the equation for the original line, y equals 2x plus 7. And right below it, I write the equation for the second line, y equals -1/2 x plus 6. At the point where these intersect, the y coordinates have to be the same. So do the x coordinates. We're going to use the fact that the y coordinates are the same by setting this expression on the right, 2x plus 7, equal to the -1/2 x plus 6, because those are two different expressions that represent y. Now, they're not always going to be equal, but there's one value of x that will make them. Once we know that value of x, we're going to be able to plug into either equation and find the value of y, so we'll know what the point is. I will do that a little more slowly. And we'll start at the top of a fresh board here. Okay, so we've got y equals 2x plus 6, y equals negative, that's 2x plus 7, y equals -1/2 x plus 6. The point of intersection the point is going to have the same y value for either equation, for both equations. The y that you get has to be the same. So 2x plus 7 equals -1/2 x plus 6. Now that's an easy equation to solve. I'll start by multiplying both sides by 2 because I have a 1/2 there. So I have a denominator of 2, and I just automatically multiply both sides by a common denominator so we don't have to muck around with fractions. There are two good reasons that we don't want to fool with fractions. One is they're a little more error prone, no matter who does them, than working with whole numbers and integers. And the other is that most students at this point are still a little bit insecure with fractions. Now we have to deal with that because fractions are going to become important, but we don't have to deal with it right now. Okay, so we multiply both sides of the equation by 2. We use the distributive law, 2 times the quantity 2x plus 7 gives us 4x plus 14, multiplying the 2 by the 2x and the 2 by the 7. 2 multiplied by negative 1/2 x is negative x. Essentially, the 2 in the numerator is divided by the 2 in the denominator. We just end up with negative 1x. And then we can't forget to multiply the 2 by the 6, which gives us 12. So now we have the equation 4x plus 14 equals negative x plus 12. We add x to both sides, and let's subtract 14 from both sides. So we're going to write the equation negative 14 equals negative 14. Going to write out what we get when we add the sides. When we add the left side to the left side, we get 4x plus 14 minus 14. On the right side, we have negative x plus 12 minus 14. Then 14 minus 14 is 0, so we just have 4x on the left. We have a negative x on the right, and then we have 12 minus 14, which is negative 2. So we have 4x equals negative x minus 2. And now we add 2 to both sides. No, sorry, we add x to both sides. We add x equals x. And we get 4x plus x equals 0 minus 2. So that 5x equals negative 2. And x equals negative 2/5. Obtaining that last by dividing both sides by the coefficient of x, which is 5. Okay. Now, does that make sense in terms of our picture? We've got a graph sitting here, and we saw that the lines cross just a little tiny ways to the left of the y-axis. Well, negative 2/5 makes a certain amount of sense there. If I made a completely honest estimate of where that point is, it might be closer to negative 3/2, okay, and negative 2/5. But because of the thickness of the chalk line and everything else, we're going to call that pretty good, especially since that last line had a little bit too much negative slope. Okay, now, where are we? Again, we're trying to find where the lines y equals 2x plus 7 and y equals negative 1/2 x plus 6 cross. We've said the y coordinates have to be the same wherever they cross, which means that wherever they cross, 2x plus 7 has to equal negative 1/2 x plus 6, because those will be the y coordinates. So we set those two expressions equal and solve and get x equals negative 2/5. So the points cross, lines cross. X equals negative 2/5. Now I'm going to do this y coordinate of the first line. B, y equals 2 times negative 2/5 plus 7. And now we're stuck having to do a little bit of arithmetic. But 2 times negative 2/5 is negative 4/5. Negative 4/5 plus 7 is 6 1/5. Y coordinate of the second line is y equals negative 1/2 times negative 2/5 plus 6. Well, if you multiply these fractions together, you're going to have a 2 in the numerator, and 2 is going to be a factor of the denominator, so 2 can divide out, and we get 1/5 plus 6, which is 6 1/5. So both equations do give us the same y coordinate. Now, if we did solution of our original set of equations to get x equals -2/5, and that was correct, and having done that many operations, there's always plenty of opportunity to mess it up, okay? But I seem to have muddled through it properly and gotten something that works, okay? If that is done correctly, then if we correctly calculate the y coordinate from the first equation, y equals 2x plus 7, then we don't really need to calculate the y coordinate according to the second equation. But we do need to do that because that checks. If those two numbers, those two y values come out different, it means somebody screwed up. Okay? All right, now, point of intersection is therefore -2/5, 6 1/5. Does that make sense in terms of our graph? Well, here's y equals 4, and here's y equals 8. So that's about halfway between, maybe a little closer to 8. Well, halfway between is 6, so it's a little over 6. So that in terms of the picture, it works out. Now, I urge you, when you do these problems, to actually sketch the graphs of the lines. Often, using the intercepts is the easiest way to sketch the graph, but not always. Okay? Sketch everything as best you can. You don't need to be entirely meticulous. Notice that I did all this with just a line for y equals 8 and a line for y equals 4, a line for x equals 8 and a line for x equals 4, right? It didn't give me a perfect result, but it gave me a plausible result. Well, that's the advantage of doing the graph. I urge you to hand sketch those graphs. Don't think that you understand how to sketch the graphs just because you can click the right buttons on an open math assignment. Okay? And of course, I'm asking you to, requiring actually, that you write out your work in your notebook, and I'll be taking a look at it. And so far, the work I'm looking at looks pretty good. Okay. What we've just done is called the method of substitution. I take the first equation, and I've got the expression for y here. I just replace y in the second expression by that, by the expression for y, and I get an equation that I can solve for x. I take that value of x and plug it back in to both equations to make sure I get the same thing both times. Then I'm pretty sure I've got the right point of intersection. All right. Now I want to okay. Here are two equations in intercept form. Not quite in intercept form. But I'm going to use these equations nonetheless. Okay? There's another way to solve these equations. There's another way to solve two equations, which is to write all your x's and y's on the left and the numbers that are left over on the right. And this is solution process. It's called the process of elimination. So why not B? I don't have room on this board to do this properly. So we're going to start over here. Here are my two equations. Now I'm going to give you an algorithm here, and I really strongly urge you to do as I say, okay? If you think you can shortcut it, it's on you. And maybe you can, okay? I'm going to put a 1 in front of this equation and a 2 in front of the second equation. Okay, so the first equation is equation circle 1. So when we say circle 1, for right now, it refers to the first equation. And a circle 2 refers to the second equation. Okay? I'm going to write those two, well, the first equation, I'm going to write again. I write negative 2x plus y equals 7. Not because I love writing out that equation, but you'll see how the form develops. I'm going to write below that 4 times equation 2, which means 4 times both sides of equation 2. We're going to get an equivalent equation because if the left side is equal to the right side, 4 times the left side is equal to 4 times the right side. Okay, so what I want you to do is write down just exactly what I've written down, and then in the line where it says 4 times circle 2, write out the equation you get if you multiply both sides of the second equation by 4. Yes. Okay, now, one thing before you get started, you don't want to write out 4 times 1/2 x plus y equals 4 times 6 here. Okay? Write that off somewhere else. Somewhere else in your paper where you're not going to have to do much of anything with it. So I'm just going to write it here. Negative 4 times 1/2 x plus y equals, and that's not negative 4. 4 times the left side, 1/2 x plus y equals 4 times 6. Then do the arithmetic. Going to have 4 times 1/2 x plus 4 times y equals 24. 4 times 1/2 is 2, so you have 2x plus 4y equals 24. And then you write that down here. Now don't look at what I just did. I showed you how to do it, but just use common sense. Put a 4 in front of your left-hand side, put a 4 in front of the right-hand side of equation 2 over here somewhere, and then work it out and put the resulting equation next to the instruction to do 4 times equation 2. And then if you get that, say, do equation 1 plus equation 2, where equation 1 is the equation 1 you have in the previous step. And equation 2 is whatever equation you write down here. This is the new equation 2. You don't go back to the original equation 2 because it's not going to be helpful. Okay. Now you've got to add the two equations you got right here. This is 1, and this one that you're going to write in is 2. Okay. Okay. Everybody has that despite being a little bit mathematically fuzzy, but there's really no fuzziness about it. Most people are saying, I don't want to write all those parentheses. I'm just going to put a parenthesis around the whole equation, put a 4 out in front, and then multiply everything by 4. Yeah, it's not officially a correct mathematical step, but if you do it that way, it's going to work. Careful. Okay. And everybody got 2x plus 4y equals 24, right? And now you add this equation to this equation, which means you add the left-hand sides and you add the right-hand sides. So what are you going to get if you do that? Well, you could, and officially you should, write out negative 2x plus y plus 2x plus 4y equals 7 plus 24. Okay? But the way these are lined up, it works out just fine if you just say, well, there are my x's, they're all lined up. Negative 2x and 2x gives me what? Show me with your fingers. What's 2x, negative 2x and 2x give you? Gives you 0, right? Negative 2x and 2x gives you 0. Okay? So you're going to get 0. What's y and 4y? Well, it's 5y. So you got 5y. And 7 and 24 is 31. So that equals 31. Y equals 31 over 5. Okay. Now, is that familiar? Well, if you put that into mixed number form, so you put it on a graph, that's 6 1/5, which you should recognize is what we got for the x-coordinate of our intersection point. And just to make sure everybody can see the board sees this, you see we got the intersection point was negative 2/5, 6 1/5. Now, why did we come up with the same intersection point? Well, it's because the two equations, negative 2x plus y equals 7 and 1/2 x plus y equals 6, are completely equivalent to the original two equations, y equals 2x plus 7, y equals negative 1/2 x plus 6. All I did to the y equals 2x plus 7 equation was subtract 2x from both sides, which gave me y minus 2x equals 7. That was my first equation. Well, it's negative 2x plus y. And to the second equation, I added 1/2 x, giving me y equals 1/2 x plus 6 equals 1/2 x plus y equals 6 is the way I wrote it down and the way you've been working on it. So these equations are totally equivalent to the two equations. And what we're getting in this solution is totally equivalent to the solution that we got previously. Now, we can take our solution, y equals 6 1/5, okay? Or 31/5, and I'm going to prefer the 31/5 because I'm going to put it into the equation. If you put 6 1/5 into the equation, then you got to convert it back to 31/5 before you go on. So we're just going to use the 31/5. We're going to substitute that in any case You want to substitute into the first equation or the second? Hold up a one or a two. Let's see a two. Yeah, okay. Well, it's a two in a default, so we're going to call it two. Okay. Uh, so I'm just going to use arrows to show what we're doing. This is y equals 31/5. I'm going to draw an arrow from that solution up to the y in the second equation. Now you don't have to do that if you're visually impaired. You're just going to plug 31/5 for y into one of the equations. But visual connection is helpful for people who think and process things visually. So these arrows indicate we substituted 31/5 for y, and now we're going to bring the resulting equation down here. The original equation is 1/2 x plus y, but y is 31/5. And that's equal to 6. So now we have the equation 1/2 x plus 31/5 equals 6. You're going to be much happier if you multiply by the common denominator. The least common denominator is 10. 2 times 5 is 10. So we multiply 10 times 1/2 x plus 31/5 equals 10 times 6. Giving us 10 times 1/2 x plus 10 times 31/5 equals 60. Well, 10 times 1/2 is 10 halves, and that's in front of x. 10 times 31 is 310, but I'm just going to write 10 times 31 over 5. Then I'm going to want to divide the 5 into the 10. I don't want to have to divide it into 310. Okay? And then on the right, I've still got my 60. And then I do my divisions, and I get 5x plus 61 equals 60. Now, I'm going to get 2 times 31. 2 times 31 is 62. I discovered that because I was looking ahead and realized it wasn't going to work. Okay. There's a bonehead error there. 5 goes into 10 twice. 2 times 31 is 62. Then we solve. I'll write out the steps. Add negative 62 equals negative 62 to that equation. We get 5x equals negative 2. Divide both sides by 5. And you get x equals negative 2/5, which is also familiar. Okay. Now, our overall strategy, when we have two equations like this, is to multiply at least one of the equations by some number. Sometimes we have to multiply both equations by different numbers, so that when we add them, one of the variables goes away and we can solve for the other one. So let's just try that. Let me give you another equation. Here's a system of two equations. 2x plus 6y equals 12. 3x minus 3y equals negative 6. I'm going to label these equations off to the right. I'll call this equation. First one, equation 1. Second one, equation 2. 1 in a circle, 2 in a circle. Off a little ways to the right of the equations so we don't confuse those with numbers actually in the equations. What would I multiply by which equation? Or would there be two different numbers that I'd multiply the same equation by in order to eliminate either x or y? Can you find a number which when you multiply by one of the equations and add them? Well, you're trying to match up the coefficients of x and y, right? And you can multiply by any number you want. You can multiply one equation by one number, the other equation by another number, if you need to. Okay? So what do you think? Okay, we have two possibilities. Our x's, we have a 2x and a 3x. So if we're trying to get rid of x, well, what if we multiply the 2x by negative 3 and the 3x by 2? Okay, 2x times negative 3 would give us negative 6x. 3x multiplied by 2 would give us plus 6x, and the x's would go away, right? Another alternative, we could just multiply the second equation by 2, and we'd have a 6y in the first equation, and the negative 3y in the second equation become a negative 6y. Now, there'll be problems in your homework where you've got to do multiplying the different equations by different numbers. But there'll also be some where you can multiply just one equation by a number. The point is you can pick on x or y, it doesn't matter. Okay? So what I'm going to do is I'm going to pick on y. I'm going to write the first equation down, and then I'm going to do 2 times the second equation. And I do have a little writing here that I want to get rid of. Need it now. Now, if you got to write 2 times equation 2 off to the right, well, yeah, you could write 2 times 3x minus 3y equals 2 times negative 6, which would give you 6x minus 6y equals negative 12. So that when you do 2 times the second equation, now you know what to write down. Okay, so I'm going to write down the first equation, 2x plus 6y equals 12. And 2 times the second equation is going to be 6x, it should have been an x, minus 6y equals negative 12. So conveniently, when I add these, I get 8x equals 0. So x equals 0. Then substitute equation, and I'll say the first original equation. Since I've used the same numbers, 1 and 2, in different steps, I mean, go back to the original equation. Don't go back to the mistake you made in the third equation or whatever, okay? Go back to the original equation, and you get 2 times 0 plus 6y equals 12, which just gives you 6y equals 12, y equals 2. Then to be safe, you plug that into the second equation. X equals 0, y equals 2, then you find that you get 6 equals negative 6. Okay, well, that's what we want to get done for the next time, solving simultaneous equations. Let me just, there will be a midterm test. I'll have it in the testing center by late this week, by Thursday afternoon at the latest, so you can take it before break, or you have full week after break in which to take it. So one way or another, good luck and figure out which works best for you.